Next example, we've got the limit as t approaches 2 of 3 divided by t minus 1 minus 3 all over t minus 2. Once again, let's try direct substitution here and see what trouble we get into. You plug in the t equals 2, what do we get? We get a 3 over 2 minus 1 minus 3 over 2 minus 2. So that 2 minus 1, that's a 1. 3 over 1 is 3. Sure enough, look what we get, folks. So, off to do some algebra. Limit as t goes to 2 of 3 divided by t minus 1 minus 3 all over t minus 2. And one of the strategies we have in addition to factoring and canceling is simplifying the complex fraction and then factoring and canceling. So the way I like to do it is we're going to multiply the numerator and denominator by the smaller the denominator here, the t minus 1, which is making this fraction a complex or compound fraction. So when you multiply the numerator by this, we would have the t minus 1 factor would come in, cancel out on the first one to leave us with a 3. Here it's going to get stuck around. And on the bottom it's going to get stuck around. And remember, folks, the rule of thumb in calculus is you never multiply out denominators. I should not say never. I should say don't. It's a rule of thumb, which means it's going to work 99% of the time. The whole reason we're doing this simplification is we're trying to cancel out the factor t minus 2 because that's the one that's causing the 0 down there. So if eventually you want to cancel it out, there's no need to FOIL things out only to try to factor it out again. So you're kind of working against yourself in that case. So we've got a 3 minus 3t, and then be careful. That's going to be a plus 3. So we end up getting a minus 3t plus 6 over t minus 2 times t minus 1. We've gotten rid of the complex fraction. Oops, t is going to 2, not 0, excuse me. If you plug in t equals 2, we still get an indeterminate form, 0 over 0. Once again, the t minus 2 is what we're looking to cancel out. So looking in the numerator, what could I factor out of the numerator to get a t minus 2? Well, I could factor out negative 3. Factoring out a negative 3, remember when you factor something out, that's the same as dividing. So we left with a t there plus a negative 2, or in other words, a t minus 2. Let's cancel out. Once again, this is why it's important we've got this limit out front. Because the function negative 3 over t minus 1 is different than this function here, but only different at 2 itself. The limit doesn't care what's happening at 2 itself. Now I can just use the substitution rule here and get negative 3. The next one, assuming x is not equal to 0, find the limit of this function. So if you notice here, the limit is on the variable h, not x. So we're just going to treat x as its own number. The limit is on h only. So we're told that we can go ahead and assume that x itself isn't 0. You can see why. If x were 0, this wouldn't make any sense to start with. Once again, we have a complex fraction. If we plugged in h equals 0, we'd have a 1 over x minus 1 over x, aka 0 over 0. So the strategy is we're going to multiply numerator and denominator by the little denominators, quote unquote. So we're going to multiply the numerator by the product, x plus h times x. Coming into the first, the x plus h will cancel, the x will remain, minus the second term, the x cancels, the quantity x plus h remains. Be careful with those parentheses. And are we going to multiply out the denominator, folks? No. Ultimately, we were trying to cancel that h factor out because that's what's causing the 0. So simplifying the numerator now, we've got x minus h. So the x's will cancel out. We're then left with a minus h in the numerator. So we've got the limit as h goes to 0. The h cancels as a 1 here, so it'll be a negative 1 over x times x plus h times x. And since the limit is on h here, we can now substitute h equals 0. Because we're assuming x isn't 0, and we get a minus 1 over x squared. Now, what we did here is the same kind of machinations we're going to be doing quite often in the next chapter, at least for a little bit of the time. So remember, when you're doing a limit and there's more than one letter, focus on the letter that the limit is being taken on. In this case, we're taking the limit on h.